Hey everyone. In today's lesson, we're going to take a look at solving systems of equations using the substitution method. Now, when you're solving for a variable using substitution, you first want to isolate one of the variables or solve for one of the variables if it's possible. Then you're going to use that, plug it back into the other unused equation to solve for both. Again, you're looking for both x and y when you're solving these equations, and your solution is going to be the point of intersection between your two lines or your two equations in your system. So looking at the one we have down here, I'm going to go ahead and this one solve for the x in the second equation because that tends to be the easier one. It looks like the top one you cannot solve for x and y. You can isolate, but you can't necessarily solve. All right, so let's go ahead and do that. We get x equals 4. We have one of our variables. Now what I'm going to do is just plug it back in to our other equation here to solve for our other variable. So in this case we have x. We're now going to need to plug it in and try to solve for y. Subtract 28 on both sides. We get 4y equals a negative 4. Divide by 4 on both sides, and I get y equals negative 1. Okay, so my solution here would be 4, negative 1, and that is, again, our coordinate point of intersection between these two equations if we were to graph them on a coordinate plane. All right, let's take a look at one more example. Okay, now in this example, we cannot solve for a variable right away, so what we're going to do is we're going to look for the one that we can isolate the easiest. I think the best way to go about this is you want to look for the variable that does not have a leading coefficient. What I mean by that is we have a 3x, and a negative 4y. Notice how this one does not have a leading coefficient, does not have a number in front of it. So that's the one I'm going to try to get by itself. Okay, now I can do that by subtracting 3x on both sides, similar to what we did when we were solving or isolating variables in the literal equations section that we did recently. Okay, so I move the 3x to the other side, and now this is the equation that I want to use to solve for the other variable. Okay, so we're going to go ahead and take this expression, and we are going to now plug it into this equation. We're going to plug it in for y because that's a variable that I isolated for, so now I have 3x minus 4. In parentheses, I'm plugging in this expression, 4 minus 3x equals 14. Okay, now I'm going to distribute the negative 4, and now we're just going to solve for our x. This gives me negative 16, a 12x, and 14. Combine like terms, 15x minus 16 equals 14. Add 16 on both sides. 15x is equal to 30. And divide by 15, and I get x equals 2. All right, now I have my x value. I need to now find my y value. You can do that in a couple ways. You can plug it into any equation that you have up here. So you can use this one, you can use this one, or you can use the new one that we solved for. I like using the new one that we solved for because y is already isolated, so that's the easiest one to use for me. All right, so let's go ahead and plug in our x value that we now solved for. I have 3. Our x value is down here. It was x equals 2, so I plug in a 2 for x now, and I get y equals 4 minus 3 times 2 is 6, and we get y equals negative 2. Okay, so we have x is 2, y is negative 2, and our solution is 2, negative 2. And again, that's our x and our y, and that is the point of intersection between our two equations in the system. You can also plug these back in to both of your equations in the system just to check and make sure that your answer is correct. I'm not going to show that step. I showed that step in a prior lesson. If you're having problems with this, take a look at the video on solving equations as a good review. If you need to review how to solve equations, you need to be very strong in solving equations in order to master this section. All right, but that's everything there is to know about solving systems with substitution.